Okay, so in this section, we are not going to follow the directions and do the prediction equation. They basically create a scatter plot and then pick 2 points, which means my 2 points could differ from your 2 points, which means our equations are not the same anyway. Okay, so we're actually going to figure the linear regression line. Before we get into the actual calculation on the calculator, I need to go through some definitions with you. Okay, one is, then the author, these are in the book. The one is univariate. Univariate data just means you have one variable. You would basically be looking at just one list of data. You know, if I said we're going to graph everybody's height, okay? Well, you know, you can't get a scatter plot with just one variable, okay? So what we're going to do in this section is we're going to use bivariate data. And bivariate data means you're going to have 2 variables, like an x and a y. And with an x and a y, we can do a scatter plot. And they might list them, the x and y table might go, you know, and you can use whatever numbers you want. I'm just making up some. I can write it like this, or sometimes in the book, the author makes a table going across, and they might say, well, compare the age and the number of sick days or something like that. And then they might have their data going across. Okay, so look at how they're putting it in the problem. Okay, so we are going to create out of our data, and we're going to do this all in the calculator. They used to do all of it by hand, but since the calculator does it, that's how we're going to do it. So okay, so we're going to do they used to do it by hand, but we're going to do it all on the calculator. And it's a scatter plot, and it's bivariate data. Graphed as ordered pairs. Okay. And part of the reason you do the graph then is to figure if there's a correlation between the 2 variables. It's called a correlation, and a correlation is a relationship or connection between 2 or more variables, and we're just going to look at 2. And the author goes through basically looking at the correlation. And if you, I'm going to give you kind of a graph, just do a kind of a sketch of this. Like if you did something and you graphed your scatter plot, you know, and it looks something like this. If you can draw a line and those points are close to that line, okay, and that is tilting in the positive direction, this one would be a strong positive correlation because it has a strong positive slope. Yeah, it's still positive. Yeah, if it's close to the line, if they're close to a line like that in a positive slope, yeah, then it's a strong positive. Okay, if you had them going, you know, yeah, and I might end up with something like this. I have a line here, maybe I even have a data point out here. It's still, that would be a strong negative. If they're close to the line, that's a strong negative correlation. If you have your data and it's just all over the place, okay, and it's not close to any line, then you just say that's no correlation. And part of the thing for this too, you may think, well, I'm not going to really need this, but down the road, if you're thinking you're going to get a college bachelor's degree, almost all of you will end up in a statistics class, because almost all majors require one statistics class, and this goes into that. Okay, Then if you have maybe I have some points that look like this, and I could still draw a line going through there, but maybe they're not close to that line, then this is a weak positive correlation. Okay, to see that if they're graphed and it's still in a positive direction, but they're not, all the points aren't close to the line, okay, then it's weak. Okay, then what we're going to do in here is we are going to take and we're going to graph a scatter plot. Then we're going to do that line, and it's called a linear regression line, and you use that line as a predictor for another element. Okay, so this is called the linear regression line. And it's called the line of best fit. It's a line that is calculated so that it's a line that is calculated so that the distance of all the points to the line are at a minimum. And what they're really figuring is the vertical distance from each point to the line is at a minimum for the line of best fit, and it is used as a prediction equation. When we look at that line of best fit, we're going to calculate the slope, we're going to calculate the y-intercept, we're also going to calculate that correlation coefficient. Okay, on the calculators, when I first did this, we did the calculation, and some had the R value, the correlation coefficient is the R value, and some had it on the calculator show up, and some did not. So I had to go back and look it up. What you have to do, if it does not show up, is you go to second function catalog, and I'll show you how to do that. If it doesn't show up, you go to second function catalog, you scroll down, or you can use second function alpha, and you go all the way down to where it says diagnostics, and you need to turn the diagnostics on. And then it will show up. The correlation coefficient is going to end up to be an R value that's between 1 and -1. If it's close to 0, if your R value is close to 0, then there is no relationship between your two variables. There's no correlation. If it's close to +1, then there's a strong correlation. If it's close to -1, then there would be a weak correlation. Okay, so we're going to look at example 2 on page 94 in your books. Okay, so open your books up to page 94, example 2. Okay, if you look on there, it says, this table shows a life expectancy for people born in the United States. Okay, their age, year of birth, and their life expectancy in years. Okay, so let's go ahead and put the data in there. In case somebody doesn't have their book, it'll make more sense. So We're talking the year of birth, and we're talking their life expectancy. You can abbreviate that. Okay, and we're looking at 1980, and their life expectancy would be to live to 73.7. 1983, I have 74.6. 1990, I have 75.4. 1995, I have 75.8. For 2000, 76.8. And for 2006, 77.7. Okay, so that's the data that we're going to do. Okay, we're going to go in and create a scatter plot first. But to create a scatter plot first, because my calculators have been used last year to do scatter plots, we need to go out and clear all the lists of data that are on the calculator. That's the next thing. Okay, so on your calculator, first clear out any equations that you might have in there. And just watch for a minute. Above the plus sign, where it says mem, you do have to be very careful with what you're doing on this. Second function, mem. Okay, this menu should come up. See number 4? Number 4 is like, that's one of the quickest ways to clear all your lists. So just press 4 and enter. So do second function mem and do number 4, clear all lists, and press enter. And it should just say done. Okay, right above the plus sign, and you have to do second function mem right above the plus sign. So first thing we're doing is we're clear all lists. Okay, and it's under second function. If it's a key, I usually circle it, and then the plus sign, the mem, and then if you just press number 4, it takes you to the clear all list. There are at least 4 ways to clear the list, but I think this is the quickest way. Okay? Okay, now to enter this data, okay, to get anything into the calculator as a list, you use the stat key. See where stat is? Press stat. And to get any stat keys right here. Okay? Stat. Okay, stat key. Press that key. And to get anything in, you have to go to edit. So just press enter at the edit. Okay, and try to get your cursor over to the L1. Okay, now let me stop there. Everybody okay with that? The cursor needs to be right below the L1, not on top of the L1, right below it. Okay, like mine. Okay, now we are going to enter this data. Okay, I recommend you use both hands. I put this hand on the enter key, this hand, type it in. So we're going to go we're going to put this in L1 going across. We're going to type this in L1. So do 1980 and press enter. Do 1983, enter. 1990, enter. 1995, enter. And if you make an error, we can insert, we can go back and type over it, we can delete. Okay? So type those numbers in L1. Got them in? Okay. Now we're going to type this list in L2. Okay. So use your right arrow key. Right arrow once, it takes you up to L2. Okay. These have to be paired up. So for 1980, we want 73.7 and enter. 74.6 and enter. 75.4, 75.4, 8, 76.8, and 77.7. Okay. Everybody done? Okay, now as a check, because I could have made a mistake, you could have made a mistake. Go back to the home screen, do second function quit. Takes you out of that. Okay, so we're going to do second function quit, get back to the home screen. Okay, then we're going to do stat, right arrow over to calculate. Okay, so now we've got the data in, we're going to do stat, and then we're going to do right arrow over to calculate. Okay, then we put in two variables. Go down to two variable statistics, okay, and press enter. And then press enter again, so you have to press enter twice. Okay, you do stat, right arrow over to calculate, go down to two variable statistics, press enter and press enter. Okay. Just wait a minute. Okay, so we agree that we've entered all the data correctly. Now we have to create the scatter plot. Okay. Okay, to create the scatter plot, we're going to go to do right above the y equals, do second function y equals in the upper left hand corner. So right up here, you're going to do, see right above the y equals where it says stat plot. Okay, so you're going to do second function y equals. This menu should come up, should say plot. Okay, once that menu comes up and you've got, notice we can do three different plots at once. You can do, and we want to do the first one, just on number 1, press enter. And then it's going to come up and say, it says on or off. You want to press enter for on. Notice this is the scatter plot. We can do a scatter plot, we can do a plot over time, we can do a histogram, we can do two different box and whisker plots. We want to stay on the very first one. Looks like a little scatter plot. Okay, should look like this with the little scatter plot. Okay, notice it already by default picks L1 for our first list, L2 for the second list, and you have a choice of the mark that it uses. I like to use that first one because it's easy to see. Now, we could end up doing our own window. The mathematicians are lazy. We're going to let the calculator do it. Okay? So, to let the calculator do it, do zoom on the top row. Do zoom. Scroll down. Okay? I'm at zoom on the top row and scroll down. Oh, looky there. Zoom 9. Zoom stat. There's under the zoom key at the top. And then 9 is zoom stat. That means that's a user-friendly statistics window. It's going to look at, the calculator is going to look at the data we entered and pick a user-friendly. So just press enter, and you should see your scatter plot show up. Okay, so we have a scatter plot, and they don't all line up. You know, we've got some points, okay, going through. Okay, now what we want to do is create the line of best fit. Okay, so to do the line of best fit, okay, so now we're going to do that line of best fit, and to do the line of best fit you got to go out, so do second function quit, go out to that home screen. You can just press clear that data off. Now we're going to figure out what's the slope and what's the y-intercept, and we're going to let the calculator figure it. So press the stat key again. Right arrow over to calculate. Okay, and do you see number 4? Number 4 says linear regression. Now there's two. And if you go on into calc, we do linear regression curves. We do cubic, quadratic, cubic, quartic. We do logarithms. And notice on number 8, it's linear regression, but that's the other one. So we want to do number 4. It says linear regression ax plus b. I have no idea why they used a instead of m. Remember our equation y equals mx plus b? No, we're doing it right. We're doing it right. But I don't know if it was easier for Texas Instruments to program in an A on the screen or what. But, okay, so we're going to do number 4 and press enter. Okay, when you press that, you should end up with y equals ax plus b. And I'm just going to put part of this on here. A should be about 0.144, and that continues on. B is about negative 211. That's our y-intercept. Okay, and then I have an r squared and our r value. This correlation coefficient is real close to 1. So this means the year that you were born and your life expectancy is a real positive correlation between the year that you were born and your life expectancy. Some of you did not get this on your calculator. So what you have to do is above the 0 where you see second function, you have to press second function and catalog. Just those of you that did not get that, do this with me. If you got it, don't just sit there a minute. So do second function catalog. Notice the upper right hand corner, there's the green, the alpha symbol, the A. I can scroll down to the D's, but that takes a while. Every keyword on this calculator is under catalog. Okay, so if you're a programmer, that's a valuable thing to know. Okay, but I can do the green alpha key, alpha, and the D. A green D is above the x to the negative 1, so I can do alpha, D. Oh, come on. Alpha, D. There, it goes down quicker. And then you can scroll down to where you see diagnostic. You need to turn the diagnostics on. And that will get the R to show up. Okay? And then just press enter. Yep, diagnostics on. Okay? Okay, so our R value indicates we're going to have a strong positive correlation because it's close to 1. Okay? So that's going to be a strong, the 0.99 is a strong positive. If you'd have a negative 0.99, you'd have a strong negative. If it's close to 0, you don't have a correlation. Okay, now, I do not want to type in all those decimals. Okay? So, what we're going to do is we're going to paste that information into the y equals, and then we're going to graph it. So, get your cursor on y equals. Up here in the upper left hand, press enter. So that you're where it says y equals, the upper left hand. Yep. Okay, press enter. Get your cursor on y equals. Yep. Okay. Now, to paste it, okay, you're going to do the vars key, V-A-R-S. Okay, so I need to write some of this down. We did the y equals, so our cursor has to be here. And then we're going to press the vars key. The vars key is right beside the clear key. Okay, press vars. You see number 5, statistics. Press that. Number 5. Okay, then go over twice. Right arrow over to EQ for equation. And then number 1 is regression equation. Press enter. Pasted all those decimals in there. Okay? Anybody need help? Okay, now we've got it pasted into the y equals. Okay, now press graph. The graph key. In the upper right hand corner, press graph. Yeah, and you should have your data, okay, and you should have a line coming through there. That is the linear regression curve. So, on the homework, some of those it says do the prediction equation. We're not going to do that. We're going to do this, the linear regression equation. I changed the directions. And then the very last part says write the equation of the line. So our equation, if you go back, and let's go like 3 decimal places. So you'd have like y equals 0.144. I'm going to round it to 144x plus a negative 211.432. So that's our linear regression equation. And then it wants us to predict it. On this problem, it says predict the life expectancy if you were born in 2025 according to this data. Okay? So we need to figure out if x is 2025. If you were born in 2025, what's the y? Okay, to do that, if you go back to our graph, okay, and I need to have 2025 in the window. So I need to figure out how far over does this graph window go. So go to the window key up here. My x max is 2008. Okay, that's not big enough. Okay, so let's go 2030, and let's go 90. Sorry. Oh, sorry. That was it. What was that? What was it? 75? 70?
73.
Okay, 73. Let's go to the y max. Let's make it 90. Okay. Okay. Now graph it. It changed your window, but that's so that we can do this. Do second function right above the trace key. We're going to do second function calculate right above the trace key here on the top row. Do second function calculate value. We wanted to figure it at 2025. So put in 20. You can, but it's easier this way. So y equals 80 point. Let's go 3 decimal places. 374. We'd have to round it. So if you were born in 2025, according to this data, your life expectancy would be. Now, that's not what necessarily happens. That's just what the life expectancy would be. Okay? So let me go back through that again. First, we had to check the window. We had to change the window. We had to make sure you can't put in a data point in x equals that's not in the window. It would give you an error. Okay, so like if I go back and change this window, it was 2008, and if I did second function calculate value at 2025, it is going to give you an invalid dimension error, an invalid error. It has to be whatever data point you put in has to be in that window. So I chose on the window. I made my window 20, because I was putting in 2025, I made the window 2030. Okay?
Wait, what are we doing? Like second function calculate?
Yeah, I did second function calculate right above the trace key.
Oh, okay.
And then I did value at 2025. And it locates the point on that. That's the whole reason you do a linear regression, is so that you use it as a predictor. Okay? So, okay? So you got to make sure your window, that your data point, and then we did second function calculate, and that's actually above the trace. I guess I should say that's above the trace key. Second function calculate, and we did value, and we did x equals, and then you put in whatever they give you in the problem, 2025, and press enter, and it will give you the y value on that linear regression curve.